Hello and welcome back. For this video we're going to discuss how to graph quadratics, and we're going to graph the quadratics in this form of ax, and this should be squared plus bx plus c, and this is called standard form. Sometimes this is referred to as general form, and these create graphs called a parabola, and the parabola is a U-shaped graph that looks like this, or it could go upside down and look like this. And a couple of the key features that we're going to talk about down here, one that's not mentioned, is this C value right here is your y-intercept. And a couple things we need to find first. We want to find and graph the axis symmetry and the vertex and then plot them on the graph. And the axis of symmetry is found by taking x equal to opposite of b over 2a. Once we find our axis of symmetry, let's say we have a graph over here. Let's say the axis of symmetry goes like this. It's a vertical line that splits the graph in two. Then we want to input this and find the y-coordinate for the vertex. So let's say our vertex ends up being, I don't know, down here, like this. Then we're done with plotting the axis symmetry and the vertex. Then we're going to calculate two more points that are on the graph and plot them. And the way we're going to do that is we're going to create a table of values. So we got x, we got a y. Then we've got some sort of vertex value here, so we've got some sort of vertex that goes here and here. So we're going to pick 2 points either to the left or to the right of that and calculate them using our equation up here. And let's suppose I choose 2 points that look like this and like this. And then to actually finish up our graph, we're going to take this point and reflect it across my axis of symmetry. So it might look something like this. So we're going to graph those 2 points and then end up sketching our graph. So it's a U shape, might look like this. Okay, and we're going to practice one of these in a moment. And then identify if it's a minimum or maximum. Okay, minimum or maximum. A minimum graph looks like this, creating a low point. So this is a min. And a maximum is a graph that goes like this, creating a high point, which is a max. So this one right here is a minimum function because it has a low point, and specifically it's the y-coordinate of that value that is the minimum of the function. And then we want to identify the domain and range. Well, the domain on all these quadratics or all these polynomials is going to be all real numbers. So the domain is going to equal all x's greater than negative infinity and at the same time less than positive infinity. And you could say all real numbers here. Our range is going to equal a y value. Now the range on this one starts at, let's say this number right here happens to be a y value of -8. So in this scenario here, this one would be all the y's that are greater than or equal to -8 and at the same time less than infinity. So the domain tells how far right and left the graph is going, and the range is telling how far up and down the graph is going. Well, it doesn't go any lower than this because it's a minimum, so that's its low point. But it doesn't have a ceiling, so it goes infinitely up. Let's put this on a graph, and we have 2x squared minus 8x plus 6, and the first thing we want to calculate is the axis of symmetry, which is x equals -b over 2a. So in our problem here we have a value, which is this one, b value, which is the -8, and the c value, which is 6. So we have a -8, so the opposite of -8 is +8. That's what -b means, or opposite of b. A value, we have a times 2. A value is also a 2, so 2 times 2. And that ends up giving me 8 over 4, which is 2. So our vertex is located at 2, something. Now I got to figure out what the y value is. But before I do that, I'm going to go and graph my axis of symmetry. This is my axis of symmetry. So my axis of symmetry is at x equals 2. So draw a vertical line at x equals 2. So that's my axis of symmetry. And now I got to calculate my y value here. So I'm going to take this 2 and substitute it in place of x here and here. So I have 2 times 2 squared minus 8 times 2 plus 6. 2 squared is 4, 4 times 2 is 8, and -8 times 2 is -16, and then bring down my plus 6, and 8 minus 16 is -8, and -8 plus 6 is -2, so my vertex is located at 2, -2. So over 2, down 2, my vertex is actually located right there. I'm going to go put that on a table of values. So I have an x and a y, and I have a 2 and a negative 2. It's negative 2. Now I want to pick points either on the right-hand side or the left-hand side of that dot. Well, the numbers that are smaller are on the left-hand side, so I'm going to choose those, and that would be a 1 and a 0. And I'm going to substitute these numbers in place of x the way I did the 2 here. So I'm going to start with the 0. So 2 times 0 squared minus 8 times 0 plus 6. Well, 2 times 0 squared is going to be 0 minus 8 times 0 is 0 plus 6. So I end up with a 6. So 0, 6. Let me go ahead and plot that. 0, 6 right here. And then I'm going to do it again with a 1. So 2 times 1 squared minus 8 times 1 plus 6. 1 squared is 1. Times 2 is 2. Negative 8 times 1 is negative 8 plus 6. 2 minus 8 is negative 6. Negative 6 plus 6 is 0. So I have 1, 0. I'm going to go plot that over 1, 0. Okay, so now all I got to do is reflect these points across that line. So this is a 1, this is a 2. This is actually 1 unit away, so my reflection will be right here on this one. This one goes from 0 to 2, so that's actually 2 units away. So 1, 2 units away. Reflects over here. And now all we got to do is hand sketch our graph. And that ends up being our parabola. Now we want to talk about, is this a min or a max value? Well, it has a low point on it, so this is called a minimum function, and its minimum value happens to be this negative 2 right here, the lowest y value it ever outputs. The domain again, the domain is going to be negative infinity is less than x is less than positive infinity. And the range, that goes back to your minimum value. Our vertex was located at 2, negative 2. The range values don't go any lower than negative 2. So negative 2 is less than or equal to y, but this graph goes infinitely up on the range values. So that's less than positive infinity. Make sure on these infinities you don't have an equal to like we do here, because that value does actually output in the function here and here.